If we set aside the scientific missions, which always require a very specific spacecraft designs, there is a high potential of small and medium satellites to consider, using for the primary satellite applications of telecommunications and Earth observation. Regarding telecommunications, discussions are still very lively, and I assume that today's panelists will be willing to give their opinion about the value of small and medium satellites with respect to the following issue. The first one is how to select the appropriate solution with the targeted market. In particular, the fact that emerging countries are lacking widespread terrestrial infrastructure and are looking more and more at procuring their own SATCOM will certainly be a trend that will be addressed. The second idea is considering that smaller satellites are generally quicker and cheaper to manufacture than larger spacecraft. How important is the time to market concept in the choice of operators? Indeed, the operator may sometimes decide to order 2 small satellites to be orbited, one after the other, rather than 1 big satellite covering the full scope of their requirements in the long term. The third idea, which is also quite important, is about the use of electric propulsion, and not only for station keeping, but also for orbit raising. And is it an attractive solution which is going to significantly decrease the satellite weight for a given payload? When examining Earth observation, the miniaturization of electronics and optical instruments has enabled to significantly reduce the size of the satellites while maintaining or even improving their level of performance. The potential of small and medium satellites in this area is obvious and confirmed, for instance, by the solutions which are selected in the frame of the GMES program. All these questions and many others will surely be debated in this plenary event, which I am looking forward to attending. And now I have the pleasure to let Mr. Mario Cosmo start the discussion, and I will be back later with the conclusion remarks. Thank you.
Good morning all. Thank you for coming, and sorry for the weather, but it's already getting better, so by the end of the session I'm sure you can enjoy a nice sunny morning. Thank you, Mr. Legal, and thank you to the speakers. I'm honored to moderate this panel, which seems to have quite a few arguments to discuss. I like to start from my far left and give the floor to Mr. Abad to hear about his point of view and what he has to tell us about the subject. Mr. Abad, the floor is yours.
Thank you, Mario. I first would like to thank the organization for their kind invitation today to this conference, and I have 3 special reasons to thank you for this invitation. The first one is because I think undoubtedly this is the major space event of the year. I mean, without any doubt, this Congress is covering all the space activities and is gathering people from all around the world. The second reason to thank you is because being in Naples, being Spanish, I feel like at home. So it's very nice and very easy for me coming here to Naples, to this beautiful city. So thank you for the invitation. And the last reason, we need also to consider some professional reasons. I think the topic we are discussing today is a very hot topic between operators and I'm sure that we will have an interesting discussion this morning about the different point of views that we'll be showing in our presentation. So I have some charts I would like to go through to introduce the subject, even though probably the most interesting is to have an interactive discussion between the panelists and even with the different people in the audience. First of all, I wanted to show where are we in terms of getting into the context of who am I and what I should be talking about. So I am as Mario have introduced, I am the CTO of Hispasat, so I will be talking about communication satellites that fall within the intersection of two worlds. They fall within the intersection between the space industry and the telecom industry. This has some specific characteristics that we will see during the discussion, and it's important to recall about these dual precedents that we have in our business. So the business is a very dynamic and competitive global marketplace with worldwide competition. In the value chains, the services are the largest part in the value chain, more than the manufacturing side. And we also want to recall that geostationary satellites are, and they will continue to be, one of the most efficient means to providing global communication services. So, in terms of the capacity, there is a constant growth, like you see in the chart, about the capacity that we are requiring, that the operators who are requiring, due to new application services and in general the new requirements from the users asking for more capacity. This drives us to a cost reduction trend through the development of larger satellites. So the natural trend in our market is to go to larger satellite platforms where we can have more capacity and we can share the cost of the launch, insurance and platform can be shared about a greater number of transponders. At the end of the day, in our business, the key driver is the cost per transponder in orbit. How much does it cost to a satellite operator to put a transponder, the unitary amount of communication that we put in orbit, how much does it cost to push this capacity? In that sense, as I was saying, this cost reduction has led to develop larger satellite platform to carry more and more capacity, aiming at reducing the total cost. However, there are some operating needs and budget pressure that are driving to create this new market segment of small satellites that we will see now. Here I'm showing a very well-known chart from the FAA showing the prediction they make every year about the number of satellites. And I would like just to highlight a couple of things in the chart. First, you see that in the next years it looks like everything gets bigger, as I was explaining in my first chart. So it looks like for the years to come, a big satellite about 5.4 tons will be more than half of the market. While if you look a bit after, there is a recovery of this small to medium satellite market where it's showing a sustained trend in the future. So in this sense, what we would say based on this analysis is that there is a strong trend in going to large satellites, but at the end of the day there are reasons that will show that there is still room for this small medium satellite that we'll be talking about. So, and some of the reasons, we'll try to put on the table some of the reasons why we believe that this small to medium satellite can be still a very attractive opportunity. They are not well ordered. We put on the table what we have, and I'll try to comment on them, and maybe we can discuss them later on. First thing, and Jean-Yves was talking about this, is quicker access to market. Obviously, I think one of the key drivers in the selection of small satellites for the communication operators, satellite communication operators, is the quicker access to market. And we have a very recent experience in Hispasat, where we had one mission, or one satellite, Amazonas 4, that was comprising two missions, a KU1 mission and a KA1 mission. And at a point in time, we realized that the timing of these two missions was different, because we had a very strong requirement to get into the market for the KU1, for which we had a very solid business case, while in the KA1, in the broadband mission, as you all know, there is always some uncertainties about the market, and we wanted to take some time to think a little bit about the design of the mission. At the end of the process, we decided to go for two small satellites, one KU1 satellite that is being built already and will be launched, Amazonas 4A will be launched early 2014. And Amazonas 4B, we are yet completing the design of the mission, and this is giving us the flexibility to adapt the timing of the different requirements, to adapt it to the different satellites. It is also true, as a second element, that this satellite has a total lower capex. So while obviously we will normally have a larger cost per transponder in orbit, in total amount of investment, the capex required to get into orbit is lower in small satellites than in big satellites, and I'm sure that will also come to this discussion later. Another factor is that this lower launch mass make it easier to find an opportunity for the launch, even it doesn't necessarily mean, and as you all probably know, that it will be cheaper. Again, in terms of cost, it'll be probably more expensive to launch a small satellite than a big one. But in terms of flexibility and selection and availability of launcher, it gives you some more flexibility. We have also talked about the faster building time. There is also another factor related to the lower capex, which is this is making these satellites very well suited for trying new technologies, as long as the risk exposure is lower because of this lower capex. So we are also using, and we will show you some example of the use of the small satellites for introducing new technologies. These small to medium satellites are also a very interesting element for providing flexibility in the satellite fleet management and risk mitigation. You just need to consider that if you have a single very big satellite in an orbital position, you need to move the whole thing if you want to move from the orbital position. While if you're having two satellites with the same capacity in orbit, you always have the possibility to move one of the two satellites and still maintain the second one. So it gives you greater flexibility in terms of fleet management. Also about risk mitigation, being the capex lower and the risk exposure lower, obviously there is a risk mitigation factor that is important in this satellite. So we have other issues also. And Jean-Yves also mentioned at the beginning, we also believe that these small to medium satellites are a very affordable way for many countries with lower or limited budget to access to space. So countries that want to start developing new infrastructure, new space infrastructure in orbit, they have the opportunity to use this small to medium satellite. It's a good opportunity for them to start up this process. In that sense, it also facilitates the step-by-step introduction of space communication services on these regional markets. It is also more effective in terms of payload fill factor. So if you're building and leads to quicker break-even point, if you have a very big satellite with a lot of transponders, it takes you longer to fill it up and to get to the break-even, while if you are using several small satellites, you can easily adapt to the evolution of the market, and you can ramp up the deployment of this small satellite at the time that your market is deploying. So it gives you a better, in that sense, a better matching with your market evolution. It is also interesting. And finishing, it is also interesting, this small satellite, to fill an orbital slot where you have already some frequencies occupied. So not always you can have all the frequencies available in an orbital slot. So if you have a limited amount of frequencies, these small to medium satellites are also a very interesting way to occupy this. So last chart I will show is I want to just to highlight one of the experience that we are having with small satellites, small medium satellite. It's not the only one, and maybe we can talk later on, but certainly we wanted to highlight today this initiative of small GEO in the Hispasat AG1 mission, which is a PPP between ESA, the European industry, and Hispasat, which is allowing the development of a new platform. And I'm sure that Marco will go through this also. And it also allows us, on our side, it gives us the opportunity to open a new market in a new orbital position, for which we also believe that the small satellites are very well suited. So thank you very much for your attention. We will keep discussing. Thank you.
Thank you very much. Mr. Fuchs, please, the floor is yours.
Thank you very much. Thanks, Mario. Thank you, and thanks for the opportunity here to share with you our views from the European manufacturer point of view. And of course, Antonio, I'm very thankful that you had this introduction. I think the answer, or the title of this session, Small and Medium Sats, High Potential for Operators, you answered to the point, and I think we all noted there was not even a question mark in the title of the session this morning. I can say from my point of view, OHB, the company that I'm leading, is basically built around the idea of small satellites. We were created 30 years ago with the idea of small satellites, at that time more from the university sector, from the academic sector, and that concept had a fast development over the last 10 years. Of course, first with national missions for DLR, and for us, very importantly, also the national mission for the German military, the Saar-Lupe satellites. In the 90s, the military in Germany planned to have very large reconnaissance satellites, and then they opted for a small satellite constellation of 5 beta satellites, and that was very successfully implemented. And that led us to the Small GEO project that Antonio was already made reference to. We started that initiative with DLR, and then later we took it to ESA in 2006, 2007. And we were very happy to find a launching customer with Hispasat taking that risk, because at that time when the commitment was done, of course, it was not as obvious as it is now, and it's still obviously to be seen how successful that mission is. So, Antonio, thank you very much for your support and for the risk-taking from Hispasat. It was introduced already by Jean-Yves. Of course, one of the hot topics to come is how to optimize and how to move on small sats in the telecom sector. Clearly will be the electrical propulsion. This is a proposal on the table actually for this ministerial conference of the European Space Agency next month in November, very close here in Caserta. There is a proposal between industry again, with investment from industry and also an operator for that. So I think Europe looks to that topic as well. Obviously, the US is also very active in that activity. So the conclusion, I think, is that small and medium satellites have reached the market. Of course, they will not replace large satellites. We heard that from Antonio. There's always the trade to make between the time to market advantages and obviously the advantages of large satellites for the price per transponder. But in terms of the commercial view, clearly, I think it's a complementary situation in a more diverse market. And we feel as a manufacturer that this will be a sustainable market segment, so that's why we are taking the investments in this area, and we're very optimistic that that will pay off in the following years. Thank you very much.
Thank you very much, Mr. Fox. And I'd like to leave the floor to Mr. James Shilton from Boeing.
Thank you, Mario. It's an honor to be here. Appreciate the invitation. As a satellite manufacturer, I'll try to give a perspective of where we've been and how Boeing sees the small satellite markets emerging. We had an anniversary last year, 50 years in the satellite business. Our facility in California began in 1962, and the first commercial satellite was launched in 1963, built in that facility, called SYNCOM. And just for fun, as a reminder, that was a small sat. That was a small satellite, and it's instructive to think about the trends that have happened since then. What has happened is all the trends drove to larger satellites. More power was desired, obviously. Missions got more sophisticated. The consideration of aperture is important. A big satellite can give you different kinds of antenna and different apertures. That, you could argue that there are some missions where you'd end up with a 3-meter antenna on the ground somewhere. You wouldn't want that in your car or at your home. As people go to handheld devices, those considerations get important. And something happened called the Global Positioning System, which put atomic clocks in space. So we're not walking around with cesium clocks in our cars or handheld devices. And I say that mostly for fun, but there were very good reasons why the satellite industry ended up building larger satellites. All that said, where we are today is there's a lot of trends that make small satellites very desirable. From a technology standpoint, miniaturization is more possible as time goes on. That's always more. We're seeing that, Boeing is seeing that whether it's large or small, the mission is still going to drive what the satellite design looks like. I completely agree with Mr. Abad. We see it the same, that you can take more technology risk and more business risk, smaller, more incremental capital investments with small satellites. And we're seeing even in military customers, the Air Force will deliver next year 2 satellites for the SENSE program, which are small, which is the Space Environment Nanosatellite Experiment project run by the Air Force. So we're seeing very traditional government customers start to tap that market. Which brings us to what, if you wanted to get a prediction of where it's going, I'll just offer considerations. I think my colleagues on the panel are better suited to say as operators the prediction, but the considerations are largely around cost. If you assume the mission's going to drive the technology and you put the technology on the type of satellite it needs to be, the small satellites offer you a smaller and more incremental investment, capital or otherwise, which should be easier to recover. If you were to study what we might see it as competitively, what we're looking at ourselves is there is a broad spectrum of people doing small satellites. They range from universities who are doing it, you could almost argue, to learn, and so they'll accept lower reliability and therefore more operational risk. And there's other folks, governments with constrained budgets, who clearly want high reliability, but they want it at that lower cost. Across that range, we see a very broad approach to how you actually build the devices. Not sure there is a stable supplier base for small sats right now. Some in that range I described are completely vertically integrated. They're building everything themselves. And some are partnering very creatively. And so where that supply chain settles out, I think will influence where the small sat industry ends up. So that idea of incrementalism and taking more risk would probably be the first order driver. There are some costs that must be considered. Large among those is launch costs. I think there's an open question. You could define small sats from very small, perhaps as high as 500 kilograms. So there is the idea of secondary payloads. There are ESPA rings on ELDs and other launch devices where you can get pay for part of the launch, if you will. And there's also, I think, a big open question on elastic demand. Will small sats become something that if launch costs dropped dramatically, would new demand emerge in the form of small sats? And for us, that's a question. I think there have been periods when a bunch of new launchers came online 10, 12 years ago. And we've all done the studies and have varying views of whether a bunch of new demand emerged, but I think most people say that didn't. You could drop launch costs and you could have new capacity. It didn't stimulate a lot of new demand. So I think that's an open question. We're not saying that wouldn't happen, but that maybe in the vernacular, those are the small sats will be the current non-consumers of launches that arrive when the price point changes favorably. So I think that's a large consideration. There's another way to look at it, even with large satellites. There is an odd term. There is a recurring, non-recurring cost, if you will, where you've got to get each payload on a larger satellite. The payload has to be integrated onto the spacecraft base, and there is a cost to that. And small sats avoid that. So there's probably a cost around small satellites that you can directly compare to a cost in the larger satellite market that may also be a price point that stimulates. So all of that considered, we think the future of small satellites is quite bright, and we're trying to figure out how we might engage more broadly. Thank you for your time and attention.
Thank you very much. And Mr. Ekte from Antrix, please, the floor is yours.
Thanks a lot. In fact, honored to be a part of this plenary. I thank Mr. Legal, Mr. Cosmo. In fact, I come from Antrix Corporation, which is the commercial front of the Indian space program. And as I think most of you are aware, India makes a host of satellites. In fact, the largest operational satellite we build is of about 4-ton class communication satellite. And the smallest operational satellite which we built for Earth observation has been of 83 kilogram Indian Mini Satellite 1, IMS-1 series. So we see the prospect for small satellites as, right now for Earth observation, science missions, and also for certain thematic applications. That is what we perceive. And we have today 2 small satellite buses which are operational. One is IMS-1 bus, which is 100 kg class, wherein you can have payload up to 30 kilograms. And it gives you a power up to 2030 watts, where 70 watts goes for the bus system and about 30 watts for the payload. And we are fortunate that we also have in hand a very versatile, dependable launcher, that is the Polar Satellite Launch Vehicle. So IMS-1 gives us a life of about 2 years nominal. And we have today 2 satellites of this category, IMS-1 and IMS-1A in orbit. And we have another mini satellite bus or small satellite bus, which is 400 kg class, where you can take up to 200 kilograms of payload. The generated power is of about 800 watt and 200 watt for the bus system and 250 watt for payload. And this one we are carrying, in fact, as the main payload on PSLV, and we can have a mission life of up to about 7 years. And in this category, we are just on the verge of launching the satellite with Ka-band altimeter and Argos payload. It's an Indo-French mission, wherein the payloads have come from Canes, and the bus and everything, including launching, is from the ISRO side. This is going up, in fact, in the second week of December 2012. And with this, we are also carrying another 5. The sixth one is under negotiation, probably 6 smaller satellites as co-passengers from Canada, Austria, and UK. So second week of December. And in the Earth observation sector, definitely India is moving towards small satellites. The heaviest operational Earth observation satellite we have launched is the radar imaging satellite, a C-band radar imaging satellite, which weighed 1858 kilograms. We launched it in 2012 using our PSLV extended version of the rocket. So 1850, if we take it as the heaviest in the EO category, the another most workhorse kind of Earth observation mission is about 1200 to 1300 kg bus, which we have the resource sat category. And we have another high resolution imaging class, which is Cartosat, which is say about 600 to 650 kilograms. Then we have the next range, as I said, Saral 400 kg class, and the mini satellite series, which is 100 kg class. So I can proudly say that in India, we have in Earth observation alone 5 categories of, or 5 classes of buses which are all operational. So towards this gradually, the ISRO centers have miniaturized many of the subsystems. For example, the inertial reference unit, which weighed something like 15 kilograms, is today less than 3.5 kilograms. The bus management unit, about 15 kilograms to say 1.5 kilogram. Payload from 160 kg in our earlier operational remote sensing satellites, today it is less than 5.5 kilograms. And the deployment mechanisms from 10 kg plus, it is today hardly 1 kilogram. And so also the data handling units from 21 kilogram to 1 kilogram. I mean, this has been our own the research and developmental effort. In fact, the space application centers which make the payload has miniaturized the payloads. Our other centers have miniaturized the other units. So the other mission, small satellite we launched recently has been YouthSat or IMS-1A, which is actually 93 kilograms or so. Power generated is again 240 watts. This has carried a payload from Moscow University, SOLRAD, and a limb waving hyperspectral imager developed in India, and another payload from a university and one of our own centers. So what I like to emphasize here is our mini satellites are also, small satellites are also giving opportunities to quickly share some of the payloads developed by R&D centers or universities abroad or research labs abroad. So we definitely see the role of small satellites as something which quickly meets our own needs, and it is something which gives opportunities to non-space agencies, because while the satellite building is mostly with the large companies or space agencies, if a university or a research lab has developed a payload and wants to fly quickly, I think small satellite is really a big opportunity. And the other advantage, of course, the PSLV, as I told you, so far we have launched 29 small, mini, micro, whatever you call satellites from foreign countries, which were from say 1 kg to something like 350 kilogram classic payload. And these payloads were from countries like Germany, Italy, Singapore, Denmark, Switzerland, Japan, Canada, and of course many more. And we also have more than 10 or 11 small satellites in queue to be launched on PSLV, because comfortably it goes as an auxiliary payload. I think this is what I have to say right now. Thank you very much.
Thank you, Mr. Ekde. And now I leave the floor to Mr. Lenzo from Telespazio. Mr. Lenzo, the floor is yours.
Thank you, Mario. Thank you very much. Good morning, everybody. Thank you for this opportunity. Telespazio actually has started its business 51 years ago, so we can say that we started with small satellites, and we started appreciating the possibility which is provided by small satellites a long time ago. Today, we believe that one of the areas which are more promising and interesting for the usage of medium and small satellite. Sorry. Okay, good morning again. Sorry for the microphone. I was saying that as Telespazio, we believe that one of the areas which is we believe is more promising for the usage of medium and small satellites is with Earth observation application. And this because of a number of points. First of all, the possibility to use a small or medium satellite with will allow for having a quick time of deployment, which is of great importance in a number of applications. The second point is that actually the possibility to have a larger number of satellites available will allow for getting much more data, and as you know, this is very important, especially for applications where near real-time constraints are of importance. This means that instead of having, let's say, large kind of data, but which are spatial and timely constrained, we will have the possibility to have more timely defined data. Of course, this will also impose on our possibility to use this data some challenge. So I would say that this is also a pressure that this possibility is providing to the ground segment and to the people which is developing applications. Actually, we have experienced that having more data is not always automatically a way to have the possibility to use this data. A lot of effort has to be put on managing this data and on getting out of this data all the information that you need. So on the same field that more cheaper and more quick satellites will be available, also the application have to follow the same path. And this is something that actually is under the community effort, because for this application, you know, there is no so, I would say, automatic and easy development. It's something that has to be helped, and it's something which is not so easy. And this is one of the major items that has to be managed in the near future. We believe that in any case, the trend will be for more and more million satellites for observation in the next year. And as an operator, we, of course, are very supportive of this, because this will allow us to provide more service in this area. I would say that right now there are a lot of expectations, but there are not so many commercial opportunities still on the ground. And we expect this will be in the near future. We hope that there will be a fast pass from the university or the scientific approach to a real commercial approach on the matter. And of course, the operator will be interested and available for this. Thank you very much for your attention.
Thank you, Mr. Lenzo. And now Mr. Giorgio from Thales Alenia Space. Mr. Giorgio, the floor is yours.
Thank you very much, and thank you, Mr. Cosmo. Thank you, Mr. Legal, for giving to Thales Alenia Space the opportunity to be part of this panel. Okay, let's wait just, okay, here we are. So let's start going to some keywords of the subject we are handling today, and in particular what is actually our view of the advantages of having a small medium platform versus space giants. It has already been said that the good adaptability of those satellites, in particular versus the launcher market, and that includes small launchers which are becoming a real reality in this world. Then it was mentioned by Monsieur Legal, the reduced development time and the reduced time to market, which gives an advantage to services, the flexibility to multiple applications, the modularity and scalability of this kind of satellite in terms of design solution, and last but not least, the suitability of such a solution for series production, as we'll see later on, and capability needed for those are the satellite constellation. Let's start with telecom application, and these are just examples we're working at Thales Alenia Space, a space-based B, it's a product of that size, and there is a high reliable satellite with strong heritage. I mean, numbers talks by their own. Within Thales Alenia Space, there are 63 satellites which have been ordered and 54 satellites already launched. And there is a high competitiveness, which is given also by the fact that those can be used for a large variety of launchers, including Falcon 9 and Aniara. Just an example, we are in Italy, and just two examples that applies to Italy. Athena Fidus, a program that we do with our Italian Space Agency, and the Sideral 2 for our DoD, are those satellites in Italy that are using such platform. How we see the evolution of that, of course, it has been said, and it will be said in the next round, that electric propulsion is going to be one of the major differences compared with the past. So there are studies in Thales Alenia Space going into that direction, with the possibility also to use some smaller launcher, and in particular the Vega launcher. Going from telecom to observation, here is another example in which we can really benefit from that kind of production. We have the Prima platform, which is an example of a medium-sized platform which has been used in this specific case for observation. And let's see, the Prima platform. As you can see from the record here, I mean, we have RadarSat-2, we have the 4 satellites of Cosmos SkyMed, we have Sentinel-1 and 3 in development phase, and we have a Cosmos 2nd generation, which is also in development phase. So as you can see, there are a variety of satellites in this field that can have a common part, which is the platform that we've developed. Now let's go to constellation. As you can see, I mean, Thales Alenia Space is one of the major platform manufacturers for constellation. Numbers which are shown there also talks by their own. I mean, you can see more than 100 satellites that have been built in the terms of constellation, where it requires the industry heavy investment in various fields. We will see later on some particular investment that one has to do, and let's say one that I want to bring to your attention is the fact that to have such very high series production, you need to develop also specific testing facility. I mean, we do have in TAS a facility which is able to test 4 satellites a month, which have already been working for Globostar, and which is going to be work for the next future constellation. So this is kind of investment that industry does in that direction, that Thales Alenia Space does in that direction. So from the Iridium, which is the last constellation we've been able to bring in the company, we are, let's say, deriving one of the most important elements we believe for the future, which is a bus, which is bus called Elite, which can be used also for a variety of launchers. I want just to put this picture for you, the example of what is the kind of configuration we can work with in terms of launcher, and the possibility to have multiple launch for a single launcher. So again, there are all up to Atlas 5, let's say, which is the biggest one at the moment for that, and we can fly up to 12 satellites of that size in a single launcher. Of course, now the trend is to go into also study for small launcher like Vega and Taurus. So I just use the pointer to show you that's the configuration with the various possibilities we can work with. There is a last point, and it's in the conclusion is I'd like to enlarge a little bit the word operator to the word customer, because we do have an experience, and we think that this must be pushed as well, not only for the operators as such, I mean communication operator, observation operator, but also science. It's a potential customer for which can take benefit for that. And one example comes from the very recent past, in which by making use of a platform, common platform, we've been capable to serve different science missions. In this case specifically 5 science missions. I want just to point out that those missions, seen from a scientific point of view, are very different one from the other. I mean, one, let's take example Corot that looks for exoplanet, others like Jason 1 and 2, which is ocean altimeter. So the same bus has been capable to serve different objective. So we believe that the effort that we are doing in terms of the operator can also be used and must be used for our institutional customers. Thanks for your attention.
Thank you, Mr. Giorgio. So, if you'll agree, I go to the second part of our panel. I understand that there are some positive response from both the operators and the manufacturers. I mean, there is some way ahead on both sides. I mean, there are missions can be used, you know, in these medium and small, using medium and small spacecraft. I'd like to hear first from Mr. Abad and Mr. Lenzo in terms of what they think are the key drivers to increase the market by using this type of missions. And then we'll hear about the manufacturers. Mr. Abad?
Thank you. Yes, about the key drivers that you've asked, I would like first to answer Mr. Chilton about the question he was making about the elasticity of the demand to the decrease of the cost, the launch cost, and in general to the cost of this small satellite. And I would say that the elasticity is total. As I was explaining in my presentation, when we are making a trade-off between large or small satellite, the pros of the large satellites is always the cost of the transponder in orbit. And you have in front of that, for the small and medium satellite, the flexibility, the time to market, and all the other aspects that I have also introduced. So if you tell me that the cost, the total cost in orbit of a small satellite will be reducing, I'm sure there'll be more trade-offs in which you will decide for a small, medium satellite than you are deciding today. So I certainly expect that the evolution of the cost, and in particular of the launch cost, will be a major driver of this market segment. And certainly I think that will happen in the future. The second element of that I do consider as a key driver for the growth on this market is the time to market, is the manufacturing times. Also, as I've already explained, this is one of the advantages of these small medium satellites, is the time that you can get into the market that is not something you can achieve with this satellite. So the shorter is the schedule, the more advantage we'll have in terms of compensating the trade-off between price of transponder in orbit and time to market. So we are expecting that time, manufacturing time for this small satellite will be still reducing, and I think there is a good opportunity to grow the market if the manufacturer times are increasing, are reducing. And the last key driver that has also been mentioned today is about full EP system, full electric propulsion system. We're referring to satellites where not only the on-station control, but also the LEO phase is done with electric propulsion. And this is something quite recent, and I think is changing the shape of what we consider small to medium satellite segment. Because I have some numbers in my mind that I used to use as a categorization about the satellite segments. And I have in mind that small, medium satellite, we're talking about something of around 3 tons with 5 kilowatt payload power. This is what I used to think when I'm thinking a small, medium satellite. This is what I'm thinking about. While when we're talking about large satellite, I'm normally thinking about something around 6 tons, 12 kilowatt payload power. This is my fixed image of small and large satellites. This is going to change with this OLEP. This is going to change. We recently made an exercise, a design exercise internally, and we took a satellite we have already flown and we know very well, like Amazonas 2. Amazonas 2 was a 12 kilowatt satellite with launch mass of 5.5 tons. We applied all these new design full EP systems, and we got to get a launch mass of lower than 3.2 tons. That means that we could have gone from a launch in an upper Ariane 5 that we made, Amazonas 2 was 2008, I believe. From that launch in an Ariane 5 upper position, we could have gone to a Soyuz launch, which the corresponding cost reduction. And last thing I would say about EP, that is something that is in the discussion today, is about all these EP and full EP systems, there is something we need to bear in mind. The key is not reducing mass, the key is about reducing cost. What I'm trying to say with this is, let me put it in a blunt position. I don't care about reducing mass. I just care about reducing the cost in orbit. If the mass reduction is not accompanied by a cost reduction, it was nothing. What I'm trying to say is, let's put a very stupid example. If I am going to launch in Proton and I am reducing my mass from 6 to 5 tons, I don't care. I will get some extra lifetime. Probably I'll go from 19 years to 23 years. What do I care? I mean, those are very long life times that certainly we cannot assure that we will be able to achieve. The real key driver of EP is getting to lower launch cost. So.
Okay, I will try to add something. Of course, cost and time are the major key drivers, and this is obvious. And when speaking about cost, we are not referring only to the investment to make to have the satellite in orbit, but we are referring also to operational cost. That means that we expect that the reduction in mass and I would say a greater simplicity of the satellite itself will allow also reduction in operational cost. Another important key driver for us is the easiness of use. That means that we expect to have the possibility to have a reduced cost also in the ground segment and in the equipments and system that we need to operate the satellites and to make use of the data that we receive. And actually that means that we expect that all, let's say, a greater intelligence and processing capability on board that will allow us to have a simpler activity on the ground. Last key driver is, this is not a real engineering key driver, this is more a political driver. That means, of course, we have to discuss about the infrastructure on the ground for managing such data and the relationship between the institutional use of this data and the commercial use of data. Because of course you can have a very cheap system which will allow you to be very competitive by an operator point of view, but you have to face what will be a large institutional usage which will go with different logic and different routes. And the relationship between institution and commercial operator, of course, I believe it will be of paramount importance for a success of the market. And I can say this could be even more important than just some percentage of reduction in cost for the satellite itself. Thank you.
Thank you. So it looks like that, the launch costs and cheaper, operating ground infrastructures are part of this reasoning we are doing today. On the other side, in other subjects that sounded very interesting were all the technological advantages that could come from these new types of missions, and miniaturizations of payload, electrical propulsion. I'd like, starting from Mr. Fuchs, hearing what the plans are and if they have any specific activity in this line of development.
Yes, thank you very much. Yes, I think we heard very well from Antonio about that the overall costs are the driver for the industry. Of course, it's a very competitive industry, and so the manufacturing industry needs to be innovative. That's the pressure we feel and we live up to. We talked a lot about the full electric propulsion. This is one way. I think the numbers that Antonio gave, the proportions, same payload capacity from 5.5 tons in theory to down to 3.2 tons, that's a 40%, in the range of 40% saving. That is quite impressive. I mean, I don't think there needs to be a lot of discussion, is this meaningful or not? I mean, obviously it is meaningful. Yes, there are downsides. You need more time and time to market. You have to pay with more time for the orbit increasing, the orbit raising. So it will not fit every opportunity. There will be obviously still markets for chemical propulsion. If you have to react quickly, if you have a failure and then replace it quickly, obviously EP might not be the right solution. But again, it's going to be a more diverse market. There will be more complementary technologies. And clearly, I think the industry everywhere has understood that EP, for example, is one of the innovations. It's interesting because the technology is around since a long time and has never been applied. And it's interesting to see then at one moment everybody talks about it and it's hot. And so. But the time is right now. That's why we have proposed to do a full EP satellite together with the support of ESA, DLR, and other member states. Hopefully, it will be decided this November at the conference. But I'm sure that sooner or later everybody will have an EP satellite in his portfolio. This is, I guess, how the market will work if it is a success. Again, I think the beauty is that there is a competitive industry, and the pressure to innovate and be more effective, price effective eventually, is very large, and that's what we have to deliver.
Well, I'll tell you what I'll do. I'll share our approach to what you're talking about. Our market forecast would say approximately a third of the satellites over the next 10 years, the power figure in there, it would be in the range of 7 kW. And so responsive to that market, we have, some are familiar with the Boeing 702 satellite line. It's a flexible architecture, moves a lot of payloads on and off. A similar bus, we have devised the Boeing 702 SP, and that's targeted at the small GEO market. It's an all-electric propulsion satellite. We've received our first orders in March of this year from Asia Broadcast. The idea is not just to get the technology and mass down. It takes hypers completely off the spacecraft. So we have all electric, but the idea is you get the cost per transponder down, and you also get launch costs down. Not only do you get hypers off the spacecraft for the launch operator, you can dual manifest these on standard commercial launchers, Falcon, Proton, Ariane. So we think not just the technology, but trying to be responsive to the business model of the operators. We're already selling electric satellites in what's kind of a smaller market. But when considering my previous remarks about how the industry evolved, what we're seeing is us trying to innovate, and I use the electric propulsion example. It is ZIPS. It's it's a xenon-ion propulsion system adapted in a different way, so we can get hypers off the vehicle. You can't just do the technology. You have to come up with something that the operators, that saves them money to orbit. So we think the dual launch manifest, the operational cost of not having hypers and the life extension available from that will make this attractive. So that's an example of how manufacturers are.
Thank you, Mr. Egden. Do you have, could you please tell us about your plans for technological developments?
Basically, I mean, with respect to small satellites, we perceive that, clear definition of applications. Why do you want small satellite? What kind of application you want to put to use? I mean, that is quite important. And the second important thing which is associated is with respect to the ground segment. If you want many people to use the data that comes in, the ground system should be simple. Of course, the next comes the opportunity for launch and the cost. See, for example, if you want to, I don't want to talk purely from the commercial angle here. Say, if you want to have continuous observation of, say, ocean color, you just want to, say, launch a series of ocean color map. Or, say, following the Copenhagen summit, suppose you want to intensify the science or environmental monitoring, greenhouse gases, carbon dioxide, whatever. And you need a series of smaller payloads, continuous observation kind. I think small satellites come in very handy. I think that is how we perceive the role of small satellites in India. So definitely the development and effort is going to be focused in this direction. Of course, I am not having the expertise to talk of the associated technology, miniaturization, whatever. But clear definition of application is with respect to ground segment, launch opportunity, and the cost should be the criteria. That should be really driving the small satellites market in the coming years. Thank you.
Thank you. And how about you, Mr. Giorgio?
I guess most has been said. The cost is definitely a parameter for which is the major question or the major point that the operator puts on the table. I have to say that electric propulsion is an answer. It's not the answer. It's not the only answer. Cost is by definition made by the cost of operation, by the cost of satellite and cost of launcher. As far as the launcher is concerned, of course, miniaturization as well as the use of electric propulsion is an help. It's definitely an help, although it will need to be trained against other requirements. Times to service is a requirement that you definitely have, and sometimes electric propulsion is not helping in that direction. For cost of satellite, of course, we as an industry tend to say that the best you can do for reducing costs is to use a very high modularity, a very high common product, which reduce on one side the cost of the satellite themselves, but as well make easier the life of the operators, because procedures, because standards can be reused constantly. Last thing I can say is that, of course, we, Palestinian Space, are in this field. We will compete, we are competitors, and we will not leave the floor to anybody else, in particular for this new enterprise of the electric propulsion systems.
Thank you. So we are getting toward the end of our session today. Thank you to the panelists. I'd like to ask the audience if they have any specific questions on the topic for our panelists, and I think logistically the easiest would be if you can approach the desk for the microphone.
Thank you. Giorgio Saccoccia from the European Space Agency. I'm in charge of propulsion. I'd like to add just a comment on what was said on electric propulsion. The agency, of course, is a strong believer since many years on this technology. I heard very important comments on that, and Dr. Fu said that it's many years that those technologies are being assessed. We have conducted a study with our primes since 15, 20 years, and eventually we saw electric propulsion being adopted on European telecoms. But at the same time, we have also studied already long ago the way satellites with electric propulsion can work together with the launchers. We did the first study with Arianespace, I think, I don't know, 95 or something. The full exploitation of electric propulsion systems on telecoms can take place only when the satellite has been built to maximize its interaction in terms of operation with the launcher. In terms of starting, delivery orbit, for example, and reducing time to service means performance, for example, the commissioning while, or part of it, while the satellite is in orbit transfer. So all those things, in my opinion, still have to come, because going to electric propulsion is not just replacing, unplugging chemical propulsion and plugging it electric propulsion. Eventually, I think getting rid of almost 50% of that mass of propellant, which is what we have today on a geotelecom, means opening the door to complete new architecture of future telecoms. The driver might become not anymore the mass, as it was rightly said by Ms. Passat, but might become, for example, the volume of the satellite. We are going to get to a denser satellite in terms of payload. So what large telecoms today does can be done by what we're discussing today, medium or small satellite. And then things like the volume of the antenna, the volume of the radiators will be the driver. So I believe that you might, it's a comment, but you might want to add to that. We are only at the beginning of a possible new design of satellites if you want to really get maximum use of electric propulsion.
Would you like to elaborate on the comment?
I think it was a very good comment. And just to answer you that when we made, as an answer to your comment, when we made the exercise, the design of the exercise of this Amazonas 2 with full EP, I was commenting, we made the exercise to put it in a Soyuz because it didn't fit into a cylinder envelope. So I think this is the key exercise. I'm sure that we'll have to rethink all these things. What we thought as a 3-ton satellite, it might be not anymore what it will be in the future, 3-ton satellites. So we'll have to rethink all that.
Yeah, maybe I think this is a good comment because the dual launching has other constraints there. Certainly, it's the envelope, not the mass. Then.
Yves Durand. Space. I have a question specific for Mr. James Shilton. I was interested in a comment you made about small geo satellites, about the payload integration cost. You said larger satellites had higher payload integration costs than smaller satellites. And I'd like you to elaborate on that because for me it's not very clear.
Okay. The context I mean that in is the industry went to large satellites, and those satellites offer opportunities to host payloads that are secondary. And those are a form of small, those in some cases are accomplishing the missions which could be assigned to small satellites. There is a cost figure of merit, which is what does it take to adapt and integrate that hosted payload onto the existing large satellite bus. That costs something which could be compared to a small sat in its cost. So the context was that there's a hosted payload or secondary is not riding for free. It's a ride-sharing program that comes with a lot of its own challenges, and so the recurring, non-recurring was in that context, that there actually is a cost to go put a secondary payload which could be compared to a small sat accomplishing the same mission.
Yeah, Bernard Frank at the European Space Agency. I've been the Smartman project scientist, and I would say that I'm a big believer of electric propulsion, Actually, we use it together with the best launcher. We have Ariane 5 that put us in a geostationary transfer orbit, and from there, just using electric propulsion, solar power, we even went to the moon. So it's a very efficient system. But now I would like to ask you what is needed to develop a solution with electric propulsion that would serve, for instance, also for deorbiting, for disposing of the spacecraft, a unit that could be attached for a low cost and with some similarities from spacecraft to spacecraft to serve these functions. And also, how do we procure so much xenon? You know, we had the difficulty to procure a xenon for smart ones, so how much xenon do we need to serve all this electric propulsion engine?
It's an interesting question. Obviously, the xenon question is out there, yes. But I'm sure that companies like Air Liquide and others will go into this and fill that demand. If there is a demand, obviously there will be a supply. Because I think in the past it was more from Russia that was manufactured. Yes, of course, there are questions to answer. And I think the other point you made, of course, the standardization or the development in EP technology in the propulsion systems has to further advance, and there will be hopefully also systems that are that use commonality. But that is obviously from the propulsion part, something that we as satellite integrators, obviously we hope for that will be available.
I think I understood from your question that you were saying, what do we ask? We satellite operator, we're always asking for things. So I take the opportunity that you invited me to ask something on EP. Yes, we would ask for higher thrust engines, because as it's been said during the discussion, one of the drawbacks about full EP systems is the time of the duration of the LEO phase. So certainly this is limited by the thrust of the engines, and we would be expecting, satellite operators will be expecting from the industry response in terms of increasing thrust in those engines.
Thank you. We have time for one more question.
I think the previous question asks part of what concerns me, and that is disposing of the satellites at end of life and keeping track of them while they're in orbit. If they're small and they're up high, it's going to take significant delta V to get them someplace else, and it depends on the mass fraction and how much mass, and you're already volume and mass limited. So I wonder if there aren't difficulties that will present themselves in end-of-life disposal and the burden that places on mission capability.
Well, from a manufacturer's perspective, that you could think of that as a design consideration. The operator's going to expend. You're going to put some capability into your design, and the satellite operator is going to decide how much of that to use operationally and how much of that has to be used for disposal. Obviously, you want maximum operational and minimum disposal. But, I take no issue with the way you express the concern. It makes the design challenging.
Thank you. I would like to thank you all, and I'd like to pass the mic to Mr. Legal for the concluding remarks. So thank you. In my introduction, in fact, I propose that we discuss about three main issues. The first one was how to select the appropriate solution. The second one, the question of time to market. And the third one, the question of electric propulsion. And what I heard this morning clearly shows that, in fact, when speaking about small or medium satellites, there are what I would call the standard solutions, and for Earth observation the answer is definitely yes, Earth observation satellites are small or medium. For telecommunication, it has been explained by both Mr. Abad and Mr. Fuchs that in fact this is a niche market with reasons linked to low capex, addressing a new market, availability of orbital slot, or addressing new technologies and innovation. And what is really at stake for this issue of small or medium is the electric propulsion. And what I understand, in fact, this is that electric propulsion has been existing for many years. And there were satellites with electric propulsion 10 or 15 years ago, and for many reasons it has been stopped. And now there is a kind of reborn. But why is there a kind of reborn? Because there is a possibility to launch small satellites, or let us say light satellites, but not really small, because they need some volume at low price. But today, if you look in detail in the market, you see that these small satellites using electric propulsion are manifested on launchers with low price, but with no track record. And so what is quite important and what will be interesting in the coming months will be to see if these launchers with low price will have a track record, because today there are some people speaking about low price but not launching. There are some other people launching but with prices which are different, and we will see in the future if low price can be compatible with a good track record. Thank you.